Okay, folks, section 11.2, it says decimal forms of rational numbers. Now, just a couple of things before we get started on this first example. Okay, rational numbers are numbers that can be written as fractions. Not all numbers can be written as fractions. Numbers that can be represented as fractions are called rational. Okay, they're the ratio of two integers. For instance, this number, well, I've got one in the example, but -2/3, obviously this can be written as a fraction. It is written as a fraction. This is equal to -0.6 repeating. That's what it looks like as a decimal. Okay? Any decimal that repeats or ends can be written as a fraction. Not all decimals end. Can you give me an example that you know of a decimal that doesn't end, that goes on forever and ever? Miller.
Pi.
Pi. Pi does go on forever. Pi is not rational. It is called irrational. Okay? It's irrational. We're working with rational numbers right now. Okay? And we're going to talk about their decimal forms. They either terminate, which means end, or they repeat. One of those two things. If the decimal does one of those two things, we can write it as a fraction. Everybody together with me on that? Now, there's a reason why they're bringing this up right now. And Libby, I'm ignoring you for the moment because I want to get through this just for a second. And that is because we're going to be working with square roots. And square roots are frequently involved with irrational numbers. Okay? So, the square root of 81, okay, this is the principal square root. The principal square root means the positive square root. Square root 81 is 9. Okay? The square root of 64 is 8. But the square root of 75 is somewhere between 9 and 8. And since it does not come out to a nice whole number, if we take the square root of a whole number and we don't get a whole number, its answer is irrational. That means we cannot represent it as a fraction. This is going to be 56602, and then it goes on forever and ever. If it does not come out to a whole number, then it is irrational. If we take the square root of a whole number and it doesn't come out to a whole number, it's irrational. Okay? So let me just ask you this. Raise your hand. Rational or irrational? Raise your hand. Coolest. Rational. Raise your hand. Rational or irrational? Libby? Irrational. Okay? Good. All right. So we got an idea about what's happening there. Now, example number 1, and you have a calculator in front of you. Example number 1, express each rational number as a terminating or a repeating decimal. Will someone tell me, what is this as a decimal? Harrison? 57128.
571428.
Oh, 571428. 571428, 5711428, ... Okay, clearly this string of numbers is repeating. Okay? When I put the bar over it, that's what I'm saying. I'm saying every number under this bar repeats. And I can get rid of the rest of it. I don't need to keep writing. Okay? This is repeating, so can I write it as a fraction? Obviously I can. We got it from a fraction. Okay? Because the decimal repeats, we can write it as a fraction. How about this one? Just quickly. You don't even need to use your calculator, obviously. What is the decimal form of this one? Raise your hand. Ryan. 0.75. Does it repeat or does it end, Jet?
It's